Hey guys, welcome to section 5, chapter 8 of the geometry program. And in this section, we're just going to continue exploring proportions inside of triangles. And in order to do this section, we need a few more theorems. So the first one is the side splitter theorem. And this says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. All right, so what does that mean? So if you have a triangle and a line that ends up being parallel to one side, it means that x is proportional to y and z to w. And so we would write that as x is to y as z is to w, okay? Hopefully, if you haven't gotten the idea that geometry is all about the theorems, geometry is all about the theorems. So we have to know them, understand them, and then apply them. All right, so next one, this is actually a corollary to that previous theorem. And a corollary means that there's a truth that follows because of something that's already been established. And so this one says that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So basically this means that if we just extend outside of a triangle and the lines are still parallel, it's still going to hold. So you have three sets of parallel lines. And this says that A is to B as C is to D. Okay, so you can extrapolate it outside the triangle and say A is to B as C is to D. Okay, and then we have one more, this triangle angle bisector theorem. And it says that if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of a triangle. So what does that look like? So here you have an angle bisector, right? A bisector means it splits that angle into two equal parts. And again, then that says that the sides of those triangles are proportional to each other. So A is to B as C is to D. You also could have written D is to C as B is to A. Like so many of our proportions, as long as the order stays the same, then there's multiple ways that you can write them as long as you're consistent. Okay, so let's go ahead and apply these and see how we do. All right, so here we have a triangle and we have a set of parallel lines. So that tells us we can use that first theorem, which says a piece of the first is proportional to the piece of the second, and then staying consistent, we're top over bottom, right? This was the first one, this was the second, so this has to be first, this has to be second. All right, then of course we just cross multiply and solve, so 10x is going to equal 72 and x is going to equal 7.2. Yes, you might get decimals, you might get radicals. Some of the questions might have radicals in them. I would say for the most part, if you see a radical, then keep it in radical form. If you have integers, like for this one, and you end up getting a decimal, I would leave it like that. So that should be fine. Okay, let's do another one here. All right, again, we have a triangle. We identify the fact that we have parallel lines. That's the key. Like you have to be looking for which theorem we're going to apply. When I see a triangle with parallel lines, then I know that we're going to apply that first theorem. But here we have a little different scenario. I'm not looking for this guy, right? What I'm looking for is that full length of the side. So we're going to apply it slightly differently. We're going to do short side is to the whole side. So the short side here is 20, and the whole side we can add is 20 plus 4, which is 24, equals short side here, which is 25, to the whole side, which is x. All right, then we cross multiply, we get 20x is equal to 600, and x is equal to 30. So you have to match up corresponding sides, right? And sometimes we're going to have to do a little bit of the math, like adding pieces or subtracting pieces, or maybe even doing Pythagorean theorem at some point. So make sure that you're matching corresponding pieces. All right, let's look at one of these. Now we have those 3 sets of parallel lines that told us this is proportional to this, and this side is proportional to that. So we can set up 2 is to x as 1 is to 2, and x equals 4. So that one's really easy. All right, but what if we have an unknown here? Similarly, just to our triangle one, we are going to match up corresponding sides. So this represents that full length that we want. So we're going to do short is to the whole as short is to the whole. So short side, which is 2, to this whole side, which is 7. Short side is 4. Long side is x plus 6. Now, need I remind you that when we solve these proportions and you have more than one term, we have to make sure that we're going to distribute. So it's 2 times x plus 6 equals 28. Then it's 2x plus 12 equals 28. 2x equals 16, and x equals 8. Hopefully that's making sense. If we needed this guy, then we could have just set up 2 is to 5 as 4 is to whatever that guy is. But since it's asking us for the whole thing, then we have to match up those corresponding pieces the best we can. All right, and then for our last corollary, that one said that if we had a line that was an angle bisector, and we see here we have an angle bisector, so then we have to put proportional pieces together. So I do opposite and then adjacent. So x is to 3, and then from this angle go opposite to adjacent, which is 6. So adjacent means touching. Opposite means the opposite side, it's not touching. Those terms are going to become really important for us in chapter 9. So I'm going to kind of introduce them now. So we go opposite and then adjacent, and then we can cross multiply. 6x equals 12 and x equals 2. So that's super easy, hopefully. All right, and then I think this is our last one. All right, last one. Again, we have this entire piece here as 20, but really I'm solving for x, and in order to use my theorem, I need opposite and then adjacent. But I could find my opposite simply by taking 20 minus 14, and that guy has to be 6. And so now I have everything that I need to solve. So I do opposite over adjacent, opposite, which is 14, over adjacent, which is 28. All right. And then we're going to cross multiply, and you're going to get 14x equals 168, and x equals 12. All right, it's pretty simple. I think that you probably didn't need more examples than what I gave you, but go ahead and finish up your notes, read through the examples in the text, and then when you're ready, begin your assignment.